So let's go through the solution of the second problem. So here's the second problem, and it's a function defined by cases. I think it's the simplest function that you can define by cases. Okay, so it's not, because it has three pieces instead of two, but it's still pretty simple. So it's the signum function, and there's a picture of it down there, but maybe I'll draw another one right here. So you have a y-axis and an x-axis, and what does this function look like? It's -1 if x is less than 0. So here it's a constant function, -1, until you get to the y-axis. And then at 0 it's defined to be 0. And then after 0 it picks up again here at 1 and becomes a constant function. So this is the signum function, and we are supposed to evaluate these various limits. So let's look at this first one. It says, what's the limit as x goes to 0 from the plus side of signum? Alright, so here we are on the plus side of 0, and here x is approaching 0. And so we're asking ourselves, what's happening to the output? What are those converging to as x converges to 0? And the answer is pretty clearly 1, right? As x goes to 0 from the positive side, the outputs are converging to this 1, even though at 0 it's defined to be 0. So the answer to 1 here is 1. Okay, and what about 2? 2 says, what happens as x goes to 0 from the negative side? Well, look at what happens over here. I'm getting closer and closer to 0 from the negative side. And what are the outputs doing? The outputs here are, the outputs there are clustering around -1. So here they're clustering around -1, okay? So the limit as x goes to 0 from the left-hand side is -1. Alright, and part 3 here says what's the limit as x goes to 0, and then it doesn't specify a side. And this does not exist. It doesn't exist because for it to exist, the left hand and right hand limits have to match, right? This has to be the same as this for the limit to exist as x goes to 0. But since they're different, it's none or it does not exist. Okay, and now it says what is the limit as x goes to 0 of the absolute value of signum? And this maybe is worth its own picture. So what does the absolute value of signum look like? It's just going to move this branch of the function down here up here, like that. Okay, so now it's all happening above the x-axis. It's still 0 at 0, but it's 1 to the left of 0, and it's 1 after 0. Okay, so what's the limit as x goes to 0 of this absolute value thing? Well, now it doesn't matter which side you approach from, right? If you approach from the left, it's 1, 1, 1, 1, 1, 1, 1. If you approach from the right, it's still 1, 1, 1, 1, 1, 1, 1. So this is actually just 1. Okay, alright. And C says, give the equations of any asymptotes. Alright, so there are pretty clearly no vertical asymptotes. Let's look at this awesome picture. So there are clearly no vertical asymptotes. There is a horizontal asymptote. There are two, actually. This is the horizontal asymptote that's described by the line y equals 1. So that's one horizontal asymptote. And this is another horizontal asymptote, and it's described by the line y equals -1. And that's all. So that's how you do this second problem, problem 2.